I'm Kamak Shamasunuru. I created a small web application for structural equation to perform structural equation modeling. This is one of the videos which belongs to a series of presentations related to a topic called performing structural equation modeling using RGfSEM. RGfSEM is a very sleek and slender web application, server level web application, which can be installed both in desktop and as well as can be deployed across the network. In my previous videos I explained how to install this, how to execute this code. Open in RStudio and execute the code so that a full feature web application appears. And also I told how to perform structural equation modeling. I explained how to perform structural equation modeling using exploratory factor analysis. In this video, I'm going to show you how to perform structural equation modeling using CFA, which stands for Confirmatory Factor Analysis. In R, we have a wonderful library called Lavan. So in my previous, when I was explaining EFA and SEM, I happened to mention about a package called Psych. That is a wonderful library as long as the SEM through EFA is concerned. But for CFA, I would like to show you another library, and this is highly recommendable for most of the advanced level of analysis related to structural equation modeling. So the name of the package is Lavan Latent Variable Analysis. Here you can see that there's a beautiful tutorial available for this library. You don't need to understand all these things. That is why I created the web application. You can just start the application from your RStudio, just like in my previous videos I've shown you that open the script file in your left top window. You need to know very fundamentals of our programming language, especially how to manage RStudio. The left top panel deals with the script files. Once you open the script file, which you download from my GitHub page, like here, if you press download, you will have download zip link, and you save somewhere in your computer, and after that you open that in RStudio. Just go to the file and open file, and you can just go to the place where this is the file actually I downloaded. Once you open this in your RStudio, you just have to press this button, run app. Then your RStudio opens the application. If you don't like to use this browser, you can press this button, open in browser. Then your application will be taken to the default web browser of your operating system. You see here it is open in the Firefox web application. I'm not going to use this. I can continue to use this here, but I will be more comfortable in using this. The very first tab is the datasets, where you need to upload the datasets because we need to perform the structural equation modeling, and it depends on a covariance matrix computed from the dataset. Here I have fictitious dataset which I created to test this application, in which I have three factors: x1, x2, x3 comprises to one factor, y1, y2, y3 comprises to, and z1, z2, z3, or z1, z2, z3 represents factor number 3. And now we are going to do analysis, which is confirmatory factor analysis, and test whether there exist really 3 latent variables in this data, as I have assumed. So I now assume that there are 3 latent variables. One stands for x1, x2, x3. Second one stands for y1, y2, y3. Third one stands for z1, z2, z3. And to do that, we have to go for SEM menu, and here there is a sub menu called CFS Summary. Now the struggle starts. In R, it is unlike Amos of SPSS. We need to write the code to perform the structural equation modeling. There we will manage with GUI. We'll just drag ovals and square shapes where the square represents a manifest variable and a oval represents either exogenous or endogenous variable. So I'm going to show you this in my Paint application. Suppose if you are fitting a latent variable with a group of manifest variables. Usually in structural equation modeling we show the measured variable or measurement variable or observed variable or manifest variable. All of them are same. They're all refers to same. Suppose if I have 4 variables, x1, x2, x3, and all these variables, I mean they'll be having some error variables. This is called e1, e2, e3, something like that. And this is the latent variable. We assume that all of them are going to explain all these variables are going to explain this latent variable. Now the path diagram, the arrow starts from the latent variable and goes straight to the manifest variable. This is where some of the researchers are highly confusing. I encountered with one of the embarrassing situations in one of the conferences where one of the researchers started arguing with me, why do you have the arrow from this side to that side, something like that. You see, the latent variable depends on the manifest variables. That is what is the notation. So the arrow starts from the latent variable and directs towards the manifest variable. It's very simple. There's a lot of documentation, but I don't know, still some of the researchers argue so obstinately with each other about the way of drawing the arrows in. But this is how the latent structure is defined in the Lavon, and now our estimates are defined here: estimate 1, estimate 2, estimate 3, and let me call parameter 1, parameter 2, parameter 3, something like that. Suppose if my parameter 1 is 0.01, then it is going to be displayed on. This is what is called structural equation modeling, where we calculate the estimates or parameters by using confirmatory factor analysis, but not exploratory factor analysis. Please be cautious. And now we can also extend this structure diagram by assuming one more latent variable. We call it as LV2, and now the arrow takes from LV2 to LV1. Now you see we have a special situation where LV2 is something like exogenous variable which causes an endogenous variable called LV1. Since LV2 doesn't take any arrows, we refer to exogenous variable, and LV1 here is endogenous variable, something like this. This exogenous variable sometimes can also can be converted by some other variable. I call it as LV3, which in turn can be explained by some other manifest variable. So this way we can define the structure path diagrams to perform the structural equation modeling, and we try to compute the parameters or estimates for all these relationships. Okay, this is all the sum and bonum of the gist of structural equation modeling. So here in R, especially through Lavon, you just go through the documentation. We have to write the model. We have to define the model by writing the code. Whereas in MS, we are just going to drag the shapes. And to me, it is only my personal opinion. It is to me that method, like dragging the shapes and playing like a child, is a kind of it's like a playing toy kind of thing, and where sometimes I struggle if my path diagram is marginally large, so the panel cannot accommodate the entire set of relationships of the path diagram, and sometimes I need to press a couple of buttons to fit the shape within the page, and sometimes the model will not get identified. This is the most nagging problem in AMOS. If the model is not identified, it's not possible for you to get the estimates on the diagram. but Laban is not like that. I mean, there is a situation where Laban also try to take the trade-off between model identified, model not identified, something like this. So if we throw some junk to the computer, obviously the computer cannot will get confused as what to do with the data. Now it is our responsibility to supply the good data so that it is possible for us to perform some meaningful analysis which lead to kind of quality in decisions. Now coming to defining the models, it's very, very simple. Just not get confused with what is being written. We have a kind of latent tendency that whenever we look at the text and characters numbers, we tend to grow lazy. But this is very simple. I'm going to show you how to define let's go back to the data. Let me take the data again. So I told you that there are three factors in my data. I mean, I can call it as a factor or latent variable or hidden variable, something like that. Whatever the name may be different, but they're all refers to. Sometimes we also refer to as construct. There may be three. The construct is broken down into the factors. A factor is broken down into the variables. That is what is the theory. Now, since I assume that there are three latent variables, now let me get a text application. Like it can be Notepad in your Windows. As I said, this application can be used in almost all operating systems. Doesn't matter, wherever you have the opportunity to install RStudio, there you can take this application. RStudio can be installed in Windows, Linux as well as Mac. Now open the text application, because we need to supply this text application, define the model. So what did I say? I said that there are three I have three factors in my data, and all the factors y1, y2, y3, z1, z2, z3. Now I assume that there are three latent variables. All these three are going to explain latent variable 1. All these three are going to explain latent variable 2. All these three are going to explain latent variable 3. Now how am I going to draw my shape? Now we are not going to draw the shape. We are going to get the shape later. I am going to show you how to get the diagram through software, but I am just explaining you the manually. Suppose if I have this latent variable 1 first, latent variable 2, latent variable 3, it is possible for me to draw a structure in this way, where the arrow takes from the latent variable to x1. This is x1, this is x2, this is x3, and these are the arrows, because the latent variable depends on the manifest variable. So you should be very, very, very cautious of now you should know what are the relationships. At least that is what is expected to perform the structure equation modeling. If you don't know what is the relationship between the latent variable, so you need to start reading the fundamentals of structural equation 1. This is latent variable 2, and now here you have y1, y2, y3, something like that, and this is latent. And later in second stage we'll be defining relationships in between these variables. So that is a different thing. Okay, let us first define a structure where we will try to I'm sorry, okay, let it be, it doesn't matter. So we'll try to fit this data to three latent variable structure, and to do that you go to the CFA, and there you open the text file in which start writing like this, f1. This is latent variable. You can also write it as lv1, there is nothing wrong. lv1 is also acceptable, anything, whatever it is. This is, you are going to define, this is a latent variable, doesn't matter. But one thing, the relationship between the latent variable to its manifest variable should be defined by using is equal to and this tilde. This is what you need to remember. So the factor 1 or the latent variable 1 depends on x1, and this x1 should be same as the name of the variable in your application. You see here I have the small x1, so you should not get confused with the capital X1. If you write capital X1, cap X1, then your software may not be able to recognize that as a valid variable. x3, enough. Now go to the factor number 2. Let me define that. It depends on y1 plus y2 plus y3. Now go to factor 3 and define which depends or which leads to Z1, which is influenced by something like that, Z1 Z2 plus Z3. So at this level, let me stop my code here and don't press enter. So it is not I mean, there's nothing going to happen, but be as rational as possible while defining the model through text application. Now you need to save this file, and while saving the file, please see that you have a consistent path, and then name of the file must be some valid name like my model. And now, or you can also write as model, there is nothing wrong, or SEM model, it is all up to you. Let me write it as SEM model dot, but here you need to be very cautious. The format of the file must be LAV. This is a Lavon file, so that care you need to take care of. Now remember, the file name is SEM model and .lab, something like that. Now keep it as it is. Come back to the web application. Now go to the CFA, browse part of the file, the path of the file. Where is it? SEM LAV, my model LAV. Yeah, SEM model LAV. Open. Yeah, missing observed variables in the dataset x2, x3. So we did mistake x1. Yeah, correct. There is no variable called x2, x1. We forgot to put the plus sign here. Now save, keep as it is. You don't need to close this, and because we'll be coming often here and changing the. Now again browse, go for SEM model lab and open. Now you see you have a beautiful output. Now this is what is the output for confirmatory factor analysis. The confirmatory factor analysis shows that the p-value is 0.43. Sometimes in Lavon, unlike in MOS, the p-value always will be 0 for good structures. I mean, the structure which has good as a fit. We're going to see that in the future. This is the minimum function test statistic, which means after solving the objective function, I said in my previous video that we are just actually performing numerical optimization on an objective function in which we have sample covariances and the population covariances. So we are just trying to find the difference between the population versus the sample, and trying to test that difference whether it is statistically significant or not. Now if you see the p-value, it's very clear for us that the differences between the sample covariances and the population covariances are the estimated covariances. Not estimated, but the sample versus the population are not statistically significant. So they are more or the same, something like that. Now, okay, let me stop here. And you may ask me a question. This is okay, fine. This is a numerical analysis. But where is the diagram? Because we all adapted to, somehow we have been brainwashed by the IBM. Like define the diagram, then get the analysis, something like that. But here, define the model and get the analysis, something like that. And the last one is going to be the diagram. We are not very much we don't give very much importance to the diagram, but the world is very crazy for the diagrams. We have a solution. I use the site package in order to create the diagrams. In case if you want to visualize the structure diagram or the SEM diagram for this path diagram or the path model, whatever it is, you just have to go here, structure plots and structure diagram. You see you have a beautiful diagram here. Suppose you want to make so I'm going to talk about the reports later, end of the video. So this is the SEM diagram for the confirmatory factor analysis, which we performed on this data set, in which we assume that there are 3 latent variables. Okay, now let's go and see. You see the latent variable f1, f2. These are the names which we defined in the text file. Okay, f1 is being explained by x1, x2, x3, 0.9, 0.8 and 1. They are very good loadings, estimates, and f2 is being explained by y1 and y3. But where is the y2? Y2 is not there. I don't know. Do I really have? Yeah, I'm sorry. These are the mistakes that we do in. Okay, now save again and go back and upload. There's nothing wrong. So we didn't do anything such a abominable mistake. Okay, now f1 is being explained by x1, x2, x3, and the loadings are really very much interesting and quite meaningful. And whereas coming to this y1, y2, y3, y1, y2, both of them are 1. Oh my god, that is unbelievable. And y3 is 0.9. That's mind blowing. And now there is covariance between f1 and f2, that is minus, it's a negative. And unfortunately, factor number 3 is not being explained by Z1, Z2, Z3. Only Z1 can explain, which is actually a constant 1. This is what is the structural equation modeling performing using CFA, confirmatory factor analysis. And this is a diagram. Suppose if you would like to go for the summary, which means do you remember that we get a lot of parameters or estimates for each and every relationships. Like say for example, what is this 0.8 and is it statistically significant in my analysis? If I ask that question, then I need to go for the CFS summary, and same the estimator is the maximum likelihood, and this is the objective function, this is the minimum value, and this is the p-value for this particular fit. The structure. It talks about the goodness of fit. The chi-square value. This is just like more or less chi-square value, but not the chi-square value. Please be cautious. And then you have the statistical test for each and every parameter or estimate. So here the estimate for x1 versus f1 is 0.805, as we have seen in the diagram here, 0.805, and which is statistically significant, which means x2 significantly explains f1, something like that. And then the estimate for x3 versus f1 is 0.9, and this is statistically significant. Is there any relationship which is not statistically significant? Yes, there is a relationship, the relationship between z2 and f3, which is not statistically significant, and z3 versus f3, which is again not statistically significant. These are the p-values, and these are the covariances. Like covariances between f1 and f2 is not statistically significant, and f1 versus f3, f1 and f3 is not statistically significant, and f2 and f3. So these covariances are not seems to be statistically significant. These are the variances. The variance for x1 again, none of them are statistically significant. Okay, but the structure appears to be statistically significant, which means we have a meaningful. We can explain a reasonable theory with the help of this. Confirmatory factor analysis or structural equation SEM. So there is a hidden theory which we can explain by using these relationships between latent variables. There are latent variables, and two of the variables are really emerging, and the last one, the third latent variable, is not that interesting in the data. Now okay, fine, this is all about the confirmatory factor analysis and how to get the summary statistics, and also the diagram. I also shown you a diagram. So but how are you going to make the report? It is very simple. Just copy the entire copy and go to open the text application, start writing the report. In your report, just paste this CFA output so that it looks when I paste this information in the text application, I'm using Ubuntu 18.04, in which I have LibreOffice Writer for writing reports, and here the following is the CFA output for survey data. Then come here, table or illustration or whatever it is, some number, CFA output. Then come here, paste. We have beautiful tabular data here. Now the following is the visual for above analysis. Now we can come here, what is this figure, some number, SEM diagram for survey data, something like that. Now here you can paste so that it is, oh my god, I did not have, again pasted the same. Now go here, come here, copy image and then paste it. you have a beautiful image here. So this way you can create the reports. That apart, let's go back and see. Now suppose I want to change the my model summary. I'm going to come up with one more latent variable. I call it as f4, and now this tend to depend on f1, and same variable is also going to depend on f2. And now let's see what's going to do. I'm just creating an extra variable, and this is my SEM diagram is going to be like this. I have an extra variable, and this variable is going to depend, and this variable is going to depend on f1 and f2. This is called f4, and I can also choose to f4 also. All these three factors again going to define by f1, f2, f3. And now what's going to happen? So this f1, I am assuming that there is another latent variable which is being explained by, or I can just confine to the first two. Let me delete this. Yeah. Now let me say that there is another. Let me assume that there is another latent variable, and which depends on f1 and f2, but not on f3. So now let us request numerical analysis for this structural equations. Okay, these are the equations, the structure of equations. Like we can say the structure of linear equations or something like that. Now this time save and go back to the application. Now browse the model file and upload the file. Now it will take a little time. I mean, it won't take time, but you see here we define f4, and of course it has some, it has a positive loading, that is 1.6, which is unlikely. Anything greater than 1 is unlikely, and for f1 it is 1, which seems to be a constraint. You need to read a little bit more about the structural equation modeling to understand. Now, yeah, of course we have positive loadings, but there may be a possibility that we can define one more. And now you see, this is the cause effect which is caused by f1 and f2. The f4 is an effect, which is because I don't have the context here, otherwise I could have explained you through, like say for example, if you can imagine that f4 is a satisfaction, which is an effect of the perception and attitude of the patients in some certain survey of individuals. Now f1, which is satisfaction, has a positive loading through f2 and through f1. So it is possible for us to assume that the satisfaction maybe depends on the attitude and perception, something like that. So that that context you can make through your survey data. But I'm just the objective of this video is to explain how to perform the structural equation modeling. And now by looking at the outputs, you see all of them are statistically significant, except the Z1, Z2. But whereas coming here, the relationship between f4 and f4 and f1, f2 seems to be is not statistically significant, and the covariances between the f3 and f4 is also not statistically significant. So this particular assumption, this relationship, dependency or cause and effect relationships, which we assumed, does not appear to be statistically significant, and they are not going to make any difference in our theory. Now let me go back, and this time let me take f4 also depends on f3, but is not going to make any difference because f3 barely explained by one single manifest variable, and that's not going to make any difference. But let's wait, and I'm just showing you how you can tinker your model, how you can improve the assumptions, improve the model over and over through your study assumptions. If I assume that I have another latent variable f4 which is being explained by f1, f2, f3, which in turn depends on the respective manifest variables, if this is the model which I am proposing, then let me go back to the app and upload the model, and then let me wait for the that's not going to do anything. You see, this model is not identified, but this is the advantage of using R programming language for structural equation modeling. If this is the situation in Amos, I'm sure you're not going to get even the estimate, and you're not going to get this diagram with loadings. This is what I said, mentioned in the beginning of the video. R is really very interesting software where it is possible for us to, you cannot get this diagram if you are using AMOS. You see the model is not identified, but yet you have some path diagram to interpret or to explain the relationships in the data. So this model, these assumptions are not going to be, we don't have enough evidence in the data for this model. Now let me tinker a little bit. This time I am going to, I don't want to mention, let's say, how can we come up with another assumption like yeah, I can do one more thing. I can assume in this way. What I do, I have f1 latent variable 1, f2 latent variable 2, and I have f3 latent variable. This time what I do, f1 f2 are going to explain f3. Okay, and now you have the manifest variables here, don't worry. Okay, here we have the manifest variables. This can be another theory. So we are just we are proposing a model, a theory, so that we are searching for a reasonable evidence from the data. Now how am I going to do that? You remember the picture in your brain? Take this snapshot. Now what did I say? F2 and F3. We are going to define F4. I'm sorry, the arrows are going to be like this, reverse direction. F4 is going to, F4 depends on F1, F4 depends on, sorry, F3 depends on F1, F3 depends on F2. And now let's request our web application whether I have enough evidence in support of this assumption. Can I formulate the theory in this way given some certain survey data like this? This is going to be some certain survey data like this. And now let me upload the model. Yeah, we have evidence in support of this. This is did I save this? Save. F3 depends on F1, F3 depends on F2. Now which is being explained. Okay, now go to the SEM model lab, go for the CFA. Yeah, I don't think we really have reasonable, but we have, the structure appears to be very good. Like we have statistically significant relationships, and the goodness of it is the chi-square value should be close to 0, so that I mean, we don't have the chi-square value here. This is the minimum function, but it is more or less equal to the chi-square value. This is the p-value. Chi-square value is 42, which is not that significant, but okay. Since the p-value is less than 0.05, we still have enough evidence in support of the p-value should be close to 1, not close to 0. Why? Because if for maximum value of chi-square, the function value, the p-value tend to be 1. If the p-value close to 1, then we have very good fitness in the structure, something like that. Now this is CFA and CFS summary. We still have reasonable estimates with p-values. If you don't get the p-values with estimates, it means that the model is not identified. So the model which we proposed has some certain evidence in the data. Our data is able to support our theory or the model, same as we have explained earlier. But this time you see F1, F2 seems to be insignificant. They are not significantly explaining the F3 as like Z2, Z3 variables. The rest of the variables are able to explain their respective factors significantly. Now this is all about the performing structure equation modeling through CFA, confirmatory factor analysis. Now I've told you how to perform this and get the numerical analysis along with the path diagrams, which means SEM diagrams. Now people are very crazy for third important component of the analysis, which is fit measures. So here there is an option for the option to compute the fit measures. If you press this, you have hell lot of, I don't think you are going to get such a list of fit measures in any other software. You have chi-square, f-minimum. This is the minimum value for the function, objective function, degrees of freedom, p-value for chi-square, CFI, TLI, NNFI, RFI, NFI, and there should be something called GFI, AGFI, something like that. All these values must be close to, I think you know how to interpret. They're all, they are very close to. This is actually into 10 to the power of 1 minus 1, which means 0.8. That's okay, fine. And TLI, it's close to, but they're not 9. So most of the, but it is not possible to get the 9. It is too much to get a value of 0.9 in social sciences. Social sciences are not like physical sciences or chemical sciences, in which it is possible to get close to 1. If you get the value close to 1, it is always a good sign, but you don't need to worry about this. And moreover, there's a lot of criticism on the fit measures. There is always a possibility to misinterpret the results if we go by the fit measures. Okay, there is AIC, BIC, and all everything. So what else we want? We have the analysis, we have the path diagram, we also have the fit measures. That's all about the structural equation modeling through confirmatory factor analysis. So I explained what is EFA and SEM, CFA and SEM through my web application. This application is far more easy to perform the structural equation modeling compared to some of the standard tools available in the industry, just like AMOS. In my next video, I'm going to explain you how to compute the mediation effect by using this web application. Thanks for watching this video. If you like my video, please press like button and stay tuned for the new content. Thanks a lot.